Good afternoon. Our review lecture for PSWT would be on Research Designs Descriptive. So what is descriptive research? Descriptive research describes patterns of behavior, thoughts, and emotions among a group of individuals. They provide information about characteristics about the sample rather than to test a certain hypothesis. Most common type of descriptive research is to do a survey. So we select a sample of the population using predetermined questions. This allows you to describe attitudes of population from which sample was drawn. It can compare attitudes of different populations and look for changes in attitudes over time. These are usually questionnaires or interviews. We could do a cross-sectional survey, which means a survey which has one more samples of the population in a single group. It allows researchers to describe characteristics of a population or the differences between two or more populations. Successive independent samples would be a series of cross-section series, a survey of two or more samples at different times with the same questions. It allows the researcher to study changes in the population over time, but not how individuals change over time. They study people's level of trust in the government. Year 1972. Especially during this pandemic, internet surveys can be advantageous. These are inexpensive, they can contact people that are hard to reach otherwise, and people can respond at their own time. But researchers would have little control over who responds, and people without internet cannot respond, hence resulting into bias. Demographic research, it can also be done. This describes patterns of life, events, and experiences like birth, marriage, employment, etc. Another type of research that would be descriptive would be an epidemiological research, and this studies the occurrence of disease in groups of people. So psychologists may study how diseases impact people's behavior and lifestyle. They could also study the prevalence of different illnesses. So in descriptive studies, and any study for that matter, sampling is an important part of research. It's the selection of people to participate in research in order to make inferences about a larger group population. So we have a probability sampling. So remember, each member in a population has a specific probability of being chosen. We could have a representative sample. This is approximately the same as the population in every aspect. Researchers can draw unbiased and accurate estimates of the larger population. Be careful because there could be errors arising from sampling. This would be differences between the sample and the population, and this is unavoidable. So error of estimation represents how much the data sample differs from the population, and estimation of the sampling error. So this allows researchers to determine how confident they are that the sample results represent the population. So this is your confidence interval. So for example, 60% of the sample chose tide, so it's usually accurate within 4 points. So 95% probability, the true percentage who chose tide is between 56% and 64%, which is a plus or minus 4% in standard deviation. So this error of estimation is influenced by the sample size. So the larger the sample, the more similar the sample is to the population. But we have to remember that we have to have an economical sample, which is a reasonable estimate of the population. It also depends on the size of population. So sample of 100 is more representative if population is 500 rather than 5,000. And variability. So the larger the variability, the more difficult it is to estimate population values, and the larger the sample must be. And we have probability sample, the sample for which the researchers knows the probability that an individual is included in the sample. So we have this EPSEM design, which means equal probability selection method. So this is used so all individuals in population have an equal probability of being chosen. So how do we obtain this probability sample? So we have simple random sampling. So each person in the population always has an equal chance of being selected. So one must have a complete list of all the people in the population and then randomly select from the sample frame. So for example, if you want to select sample of 100 students from a school with 5,000, you would get a list of all 5,000 students and number each from 1 to 5,000. Then use a table of random numbers to produce 100 numbers between 1 and 5,000 and select those 100 students to be in your sample. This is called the fishbowl method. We also have stratified random sampling. Because there may be different subgroups within your population, such as age, gender, ethnicity, you may want to choose people from each subgroup. Cases are randomly selected from each strata. This ensures you have an adequate number of participants from each stratum. Another type of sampling would be proportionate sampling, wherein cases are drawn from each strata in proportion to their prevalence in the population. So for example, if population is 70% men, 30% women, then sample proportionately to ensure 70% men in sample. Then we have cluster sampling. This is used if you cannot obtain a sampling frame list of the entire population. This is difficult to get a list, for example, of all healthcare workers in Alberta. So we break the population into smaller groups for which there are sampling frames and then randomly choose some of the clusters for inclusion of the sample. So clusters are usually locations or institutions, or randomly choose different counties in Alberta and then get a list of all workers in those counties. It could be multi-stage sampling, so you begin sampling by large clusters and then eventually break down into smaller clusters.